I want to start out by saying the most important thing in tonight's video is that you take good notes. There's lots of facts and a few equations. This video is mostly just information. Then it needs to be in your notes so that when you come in tomorrow, even if you don't have it memorized, you can pull out your notes and work problems using the information I've given you. So this information needs to be with you in class, either memorized in your head or on your notes page. And tonight, that's especially important. I'm going to throw a lot of definitions and a couple new equations at you all at once, and you're just going to need to be able to use them tomorrow. And to use them tomorrow, you have to either know them, have them memorized, or have them on notes in front of you. So notes and memorizing, most important things in tonight's video. All right, tonight's video is going to be fairly short, but requires a lot of memorizing on your part. So you are expected to pause the video and read definitions, memorize those definitions, be ready to use them tomorrow both on the reading quiz and in answering questions. So first, you should have watched the pre-reading video of a group of students trying to shove a bowling ball in a circle. Now, what's special about that is an object moving in a circle at a constant speed. So note this, an object can be moving in a circle at a constant speed. Whoops, let me highlight that. And that object is still accelerating. So let's talk about why. When an object is moving in a circle, there is always a net force toward the center of the circle. So if this is our circle, there will be a force wherever the object is. So let's say the object is right here. There's a force on the object toward the center of the circle. And that force is constantly causing the object to change direction. Now, acceleration is a change in velocity, and velocity is speed and direction. So if your direction is changing, you are accelerating. And if an object is moving in a circle, there must be a force towards the center of the circle that's constantly causing the object's direction to change. Because what you might notice is at 1 second, let's say the object, by the way, is going this way, the object has a velocity in this direction, and then a moment later it has a velocity in this direction, a moment later in this direction, a moment later in this direction. So its direction is always changing. And that is caused by a centripetal force. It's the net force for an object in circular motion, and it points toward the center of the circle. This is one of those times when you should pause the video and memorize that real fast. Towards center. Another definition you'll need to know, centripetal acceleration. If there is a force toward the center of the circle, then there must also be an acceleration toward the center of the circle, an acceleration, and that comes from Newton's second law, F net equals ma. So if there is a net force toward the center of the circle, then there must be acceleration toward the center of the circle. And so centripetal acceleration is what we call the acceleration for an object in circular motion. And that's the definition of centripetal acceleration. You'll also need to understand what it means to make a horizontal circle or a vertical circle. So a horizontal circle might be like a hula hoop. It goes in a circle that's flat along the horizon line. So a horizontal circle might look to you something like that. It's like a pizza. It lays flat. There are also vertical circles. Now a vertical circle goes up and down, and it might look more like this, or it could look like this. So a horizontal circle is kind of flat compared to the horizon, and a vertical circle is up and down compared to the horizon. Some other quick vocab words. Instantaneous means at one instant. So we're going to talk about the instantaneous velocity of things moving in a circle, and that means their velocity at one instant. Those would be like the red arrows I drew up here. At one instant, its velocity is one way, the next instant it's another way, and so forth. We need to know the word perpendicular because that net force will always be perpendicular to the object's motion. So right here in the circle, the object might have a velocity off to the left and a net force down toward the center of the circle, and those form a right angle. So the instantaneous velocity and the net force always make a right angle. Finally, tangent, those instantaneous velocities that I drew with the red arrows above, they all go tangent to the circle. So again, if our object is traveling in this direction, right here, it would have a velocity this way, down here, this way. Notice those are all touching the circle at exactly one point, and then moving off in a straight line. That's a tangent line. Touches the circle in exactly one point, moves off in a straight line. It's a lot of vocab. If you need to watch this slide again, feel free. Go back to the beginning, watch this 4 minutes again. A lot of words to remember. I'm going to change the slide, so pause if you need to. You need to be able, by the end of tomorrow, to look at a situation and say what the centripetal force is. So you need to know the rule that anytime something is going in a circle, there is a centripetal force. You just have to be able to figure it out. You have to be able to look at it and say what the centripetal force is. You will never call a centripetal force on a free body diagram simply centripetal force. So you'd never draw a free body diagram that just said on it FC for force centripetal. It would be some type of force. So let me make that clear. Centripetal force is not a type of force, like tension is a type of force, or like buoyancy is a type of force. Centripetal force is just the general term for the force toward a center of a circle, but it's not actually a category of force that you can label something as. Maybe these examples will help. If we had a person swinging a ball around on a rope, we would need to be able to identify the type of force. And that type of force would be tension from the rope. So the rope would always be pulling the ball toward the center of the circle. Draw a general circle for us to use here. So in this case, the centripetal force would be the tension of the rope pulling the ball toward the center of the circle. If we had a marble that we put inside of a hoop, like a hula hoop or a wooden sewing hoop, and we made that marble go in a circle, there would have to be something pushing that marble toward the center of the circle. Since the marble would be touching the hoop, it would get a normal force from that hoop. So here, if we had a marble going around in a hoop, we'd have a normal force. In the video of the broom shoving the ball in a circle, you could either call the force from that broom a normal force, because it's just the broom pushing on the ball, or you could call it maybe a contact force. Either one of those would work. Here I'm going to say it's a normal force from the broom. You could also call it like force from the broom or contact force from the broom. A car driving around a track. Now we learned earlier in the year that cars always have a certain kind of friction. Whoops, I just let the answer go. Have a certain kind of force pushing them along. And so a car driving around a track, the force toward the center would be friction. The Earth goes in a circle around the sun. Think about what kind of force it is that's pulling the Earth toward the sun, toward the center. The Earth is pulled toward the sun by gravity, and so gravity is the centripetal force in that situation. So you'll never just label a force toward the center of a circle centripetal force. You'll tell what it is. It's always going to be one of these. So basically, centripetal force is not a type of force. It's a general word telling us that anytime something is going in a circle, that there is a force toward the center of that circle. It's then your job to identify it, to say, I wonder why that little toy car is going in a circle. Oh, friction must be pushing it in a circle. Or I wonder why that ball swings in a circle. Oh, the tension from the rope on it must be pulling it in a circle. Okay, so there's always a force toward the center. In fact, there's always a net force toward the center of a circle. You just have to figure out what particular force it is. To start off this unit, there are three main quantities you might have to calculate for an object going in a circle. First, it's speed. And here we're just going to use the good old, from CP physics, basic equation, speed equals distance over time. Now for something going in a circle, that distance will be the circumference of the circle over the time it takes for one revolution around the circle. And so we might have to calculate this something like 2 pi r over the t for one revolution. And you could of course do fractions. So you could say like the distance of 1/4 of the circle divided by the time it took to cover that quarter of the circle. So we'll just use the good old standard, speed equals distance over time. A new equation, though, you'll have to be able to calculate centripetal acceleration, which I'm going to call AC. And centripetal acceleration is calculated velocity squared over the radius of the circle. So that's velocity, if you found the speed up from finding speed, velocity squared over the radius of the circle. And that's the acceleration toward the center of the circle. So if you've got a circle, AC is the acceleration toward the center of the circle. Then there's also centripetal force. Now you might know from Newton's second law that a net force is a mass times an acceleration. So if there's a centripetal acceleration, that's caused by some centripetal force, and we would just plug in the centripetal acceleration here in the net force equation, and we'd get the centripetal force equals mv squared over r. And you should know both of these, acceleration, centripetal, and centripetal force. Those are quantities you'll be asked to calculate. We're going to save examples and trying that for tomorrow in class. This is mainly just factual information. If you need to rewatch anything in the video, do it. You need to know all this information coming in tomorrow. And at the very least, it should be in your notes so you can look at it tomorrow in class.